Hmm. Because this was just only for this company, right? I'll update it and I'll inform you. It is also on that. Then you apply. Okay, so today we'll see about networking and content delivery. The session is getting recorded now. So what is in the network? Okay, before we move on, let us see what are the things we are going to discuss. In this module, we are going to discuss about network basics, Amazon VPC, VPC networking, VPC security, Amazon Route 53, and Amazon CloudFront. At the end of this module, you will come to know about the network basics, security groups, and Route 53 CloudFront as well. So networking basics. First of all, we'll go. What is in the networking? Can I just say what is in the networking? Just say in your own words what you mean by networking. Yes, Anthony, Anjali, Kiran, Tanushree, Uma, Srisha, Sambara. Can you please tell me what is in the networking? You heard the word networking, right? Yes or no, guys? You're able to hear me? Guys, can you able to hear me? Yes, what is in the networking, Kiran? Say it in your own words, it's fine.
Sir, networking means like connecting to your Wi-Fi or something, or connecting to a server.
Yes, let us say connecting to a computer from one computer to another computer, another computer. Let us say these two are connected. For these two connection, I need a subnet. And these two computers connected, I need a subnetted device. This is, let us take this is sales team and this is HR team. Now connecting these both, can we able to connect these both? Is it possible? Yes or no? This is one team, that is HR team, this is sales team. Can we able to connect these two networks? Is it possible? Yes, that is called router, where we can able to route the traffic from one network to another network. Right, so we have various networking devices also. Let us see this example. Let us see this as an example. Here you see three computers are there. Let us take this A, B, and C. And this is D, E, and F. Now these are all HR and these are all sales. Sales team people will communicate among themselves using subnet. And again, the other person will take, the HR team will be able to communicate among themselves using another subnet. And these both wants to communicate, we have router. Now what is in the subnet? A network can be largely partitioned into subnets. Now, I want to configure or I want to, okay. First of all, how I can able to identify these systems? Is it like ABCD will call them, or is there any value for them? How can I identify a system? All are with same brand, same monitor, same CPU, same type of CPU. How will you identify the difference? How will you identify the difference, guys? MAC address, okay, yes. Same, we can call it as what? One more address, one more name is there, another name for it. Another name for that is what? Another name for that is what? What is the other name, guys? Same Kiran, yes, it's correct only. Can you use the other name? In Windows, what we call it as? In Mac, we call it as MAC address. Again, Windows, what we call it as? Come on, guys. You have heard this. What is that? I want to configure, or let us say, since this network is there, since this network is interconnected, I can able to pass this information to this team and this information to this team also. Now this person wants to talk only to this person. That is A. That is F wants to talk only to A. What I need to know. What I need to know. For example, the sales people are 192.168.1.1. Now 168.1.2. Now 1.3. Here it is 192.168.2.1, then 2.2 and 2.3. So what we call it as? We call that as what address? IP address. What? IP address. So this IP address is the one which is connecting all your computers separately, and will make sure you are able to identify this IP address. Now what does this IP address will consist of? The IP address will consist of a numerical decimal format. That means you can able to see this 192.0.2.2.0, right? Now what is this numerical IP address? This is in the decimal form, right? What this will do? This is converting this machine, convert this decimal number into a binary number. Binary number means nothing but, for example, binary numbers will always will have all these binary numbers. It is converting into an 8-bit octal number. 8-bit octal number. Why it is 8-bit? Let us take each of these 8 bits octal number. This 8 bits octal number, how it came? Let us see. Let us take 192 divided by 2. 192. Buried today. Another laptop is there. Inside the draw, you see somebody's laptop is there. Whose laptop is there? Oh, it was yours. Very good. In the board computer, any have is there? Any computer is there? Uh, somebody left an hour recently. Puja. She got Puja's laptop. Check any other laptop is there. If there, we take that. Others, Kumar sir, just message him. My laptop is fully dead, nothing is not starting at all. I want to replace it immediately. You mention. Mail it also. Mail it also. Phone. Hmm? And those people, three people recruiter job, huh? Ask them whether they won one placement. Because it's coming under non-IT, then again they should not come and ask placement. Check with them first, huh? Okay. Now this 8-bit octal number, let us say 192 divided by 2. So what is the value? 192 divided by 2, what is the number? What is the number? 192 divided by 2. Yes, 96. Great. Now 0. Again 2. What is the value? 96 divided by 2. 48. Okay. Again 0. Again 2. 24. Again 0. Again 12. 0. Again 6. 0. Again 3. 0. Again 2. 1. 1. So here it is 1. We are getting 1 0. So here you will be able to see 1 1, correct? So last 1 1 0 0 0 0 0 0. So that's what here you will be able to see. Now all these 8 bits, what is the highest value here? Okay, what is the binary form? So how the computers are understanding whatever we are typing? Through what? How computer is taking whatever values we are entering? Okay, in what form it will take the computers? Computers will understand in which form? Binary form, yes, exactly. What are the binary values we have? How many values we have in binary? 2, exactly. What are the two? 0 and 1, correct? Huh? So this 2 and this 8 bits. 2 power 8. 2 power 8 is how much? 2 into 2 into 2 into 2. 2 into 2 into 2 into 2. So 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32, again 64, 64 into 2, 128, 128 into 128 is 256. How much? 256. So 2 power 8 is equal to 256. So this 256 up to 256 decimal value it can go. It's not only here, it can go for here also 256, 256, 256. Starting from 0. So starting from 0, 256 total means it should be 255. 255. That's what you can able to see. It can able to go from 0 to 255. So this combination total of 4 numbers for an IP address with this 32 bit. Why is this 32 bit? Because 8 here, 8 here, 8 here and 8 here. So total 8 into 4 is equal to 32. That's what it is, 32 bits. Totally 1 bit is equal to 8 bits. And one value can go up to 2 power 8, which is 256 digits it can go. So 256 decimal values it can go. Okay, this can go up to 0 to 255 and again 0 to 255 and again and again. Okay, are you getting this? If you want, you can just write and keep it. Once you are done, you just show me a thumbs up symbol. I will move to the next one. 7:30 you just message me, I will just update you. Call 7:35. You're done means we just put a thumbs up symbol. We'll move to the next one. So the IP addresses will be having 256 numbers because it's 2 power 8. Then again it will be calling it as 32-bit binary form. Why 32-bit? 8 into 8 into 8 into 4, it is 32. You're done, just put a thumbs up symbol, guys. Okay, Kiran done. What about others? Okay, fine. We'll go to the next one. Now, this 32-bit, this is your normal computer. Whatever we are using, the normal computer will always have 32-bit IP address. You can go and check it in your IP address also. Though that in the virtual machine, that is in our AWS, we call it as IPv4 address. We call it as IPv4 address, which is a 32-bit address, which is a 32-bit address, which is 192.0.2.0. Another thing, IPv4 6, this is 128-bit address. When will we be using this 128-bit? Means when you have a higher configuration, high speed network to handle your data, then you go for this 128-bit. Now, 128-bit, why we call this as 128? Let us see. Previously, it was 8 bits behind every decimal point, decimal values, correct? Now, this time, here you see 4, 4, 4, 4, 4, 4, 4. Total 8 is there. Now, each decimal values, that is alphanumeric values, will have a 16-bit hexadecimal number. 16-bit hexadecimal number. Hexadecimal means what? 16 digits. Like you might have learned in your school or college, that is 0, 1. Next 0, 0, 0, 1, 1, 0, 1, 1. Have you learned this? Binary logic. Yes, those who are computer science or normal, I think this one will come everywhere. The logic gates, you remember 0, 1, 1, 0, and it will keep on going, right? So, same thing only. Next is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1. Right? Again 1, 1, 0, 1, 0, 1, again 1, 1 will keep on going, and 4 ones. Now that's called your 4-digit value. This one, this 4-digit value, each is having 16. So 16, 16, 16. 16, 16, 16. Now 16 into 8. 16 into 8 is how much? 128. Now that's what we are calling it as 128-bit address. 128-bit address. Okay. Now usually you'll be having this thing, 128-bit address. So when you convert this binary to decimal or decimal to binary, you might be able to see these values. That is that binary. Here you can able to see this binary to decimal values, how to convert this. So previously we done from decimal to binary, right? We put that 192 conversion. You are able to see 11100. What we've done. Same thing if the binary value, decimal value of 2 converted to binary, what is the value? 00010. Same thing below, you can able to see how to convert this decimal. Here you can see decimal to binary conversion table, 0 1 2 3 4 101.110.111. Then again 100.0.0.89. And after this one, it will become alphabets. It become alphabets. That's why this value only they have mentioned there as A, B, C, D, E, F. You will be able to see that the values are there till F. Are you able to see here? F, B, A, B, A, A, E, A, B, A, F, F. Correct? Till F alone it will be there. Till F alone it will be there. So this is called your one to eight. When we will be using this? When you need a high network, high fast network, you want to load terabytes of data faster, then you have to go for 110-bit address. But since it is a costly one, so when whichever companies want that much speed, they will take this. Okay. So you made a note of difference between 32-bit and 128-bit address, IP address. This is for higher configuration. That too very higher configuration you can mention. This is for normal. This is for normal configuration of your VM, virtual machine. Okay. So write this one or just make a note of this and let me know. Put a thumbs up symbol. Is it done? If it's done, just put a thumbs up symbol. Done. Yes or no, guys? Shall I go to the next one? Okay, Kiran done. Others done. You made a note. Okay. Now some people will get confused. So some people will get confused from your system, checking your system configuration, thinking that it is showing 64-bit, how you are saying 32-bit. So understand the difference here. It is talking about network bits. Okay, that's why I show the difference. Here in your system computer, it will show you system type, that is 64-bit configuration. That is the processor bit. Okay, now what we are talking is IP address, that is your network bits. Okay, this IPv4 address is mainly written in your digital decimal format as 8-bit field that is separated with fields. Now here it is microprocessor that can be handled with 64-bit performance large number. So there also we have the little bit processor which is slow. Normally I think now you guys have this processors, huh? So you guys when you buy a mobile also you are checking the processor. Right? Processor is mainly for what? What's the processor will do? Is having higher configuration of processor is it important? Yes or no guys? Yes, if you have a higher configuration, your system will be faster. Correct? Na? So that's processor bit. Now what we are talking about here is network bits. Next, the important one. Classless inter-domain routing. That is classless inter-domain routing. That is CIDR block range. What is the CIDR block range means? This is the one we are going to take the block level range for blocking our cloud space. For blocking our cloud space. How to do this? So first one, as usual, our IP address is same. We are able to see 192.0.2.0. In this, the first three is identifying the network identifier, which network we are preferring. That is routing prefix. Prefix means what? What we want to give the preference prefix. Now the last digits will identify the host identifier. That is, which computer is this belongs to. As just now in the introduction I drawn, right? 192.168, 1.1, 1.2, 1.3. Like that, this one. Now this will tell you, this 24 will tell you how many bits are fixed. How many bits are fixed? Fixed means what? How many bits are already fixed? What is the remaining bits? Okay. Remaining bits means I will tell you. Now this 192.0.020, is it how many bits computer this is? How many bits network is it? Is it 128 bit or 32 bit? You guys tell me. Is it 122 bits or 32 bits IP address? Just now we learned in the previous slide. Is it IPv4 or IPv6? Yes. Anthony has said 32. Correct. Now 32. Now 32 minus 24. That is this fixed one. 32 minus 24 is how much? 8. So this 8 is equal to 2 power 8. Now 2 power 8 is what? 256. So that means this configuration network can configure up to 256 systems. If you're taking zero value, then it is 255 systems you can configure. 255 systems you can configure in this network. That is how first system is 2.0, next 2.1, 2.2, 2.3, like that. You can go up to 2.255. Okay. Now this is 255. 256 IP address. 256 IP address, that is 256, 255, 32 minus 24 is 8, that is 256. 256 IP address I can able to configure in this through this network stating 2.1, 2.2, 2.3, 2.55, 255. Now instead of this 24, if I put this as 28, what? 28. Now how many numbers will be there? 32 minus 28 is how much? 32 minus 28 is how much? 32 minus 28, 4. Correct? Now here the value should be 2 power 4. What is 2 power 4 actually? 2 into 2 into 2 into 2. So 2 to the 4, 4 to the 8, 8 to the 16. So my value is 16 IP address, 16 computers I can able to connect. Now you might be imagining where we are using this. So 16 computers means like a company is having only 10 computers, 10 employees working. For them, do we need to configure for 256 IP address? Is it necessary? Is it necessary? Only 10 people are working. For 10 people, the 16 connections is enough. Is it or not? Will you purchase 256 IP address? No. Correct? So now I don't want to make my network to be established more. I have only 16 or below that, then I'll go with 28. I'll go with 28. If not, and also the common thing is the important thing is by default this cloud by default reserve cloud will reserve 5 IP address. Whatever IP address you take, in that 5 IP address it will take it as a reserve. That means, for example, 2.0, 2.1, 2, 3, 4, or instead of 1, 2, 3, it will go for 255. These 5 IP address it will reserve. Reserve means what? You reserve a seat. What will happen? Can anybody can go and sit in that place? You reserve a seat in cinema theater or bus booking. Can anyone can go and sit in that place? Will somebody go and sit in that place? No. Correct, right? Why? because you reserved. You should not touch that. We should not touch that sheet. Same thing here. Since this 5 IPRs are reserved by default every time when you launch, now 16 digits, that is 2 power 4. If it is 28 means 4, so 2 power 4 is 16. Now out of this 16 minus 5 is 11. So 11 computers you can configure it. What AWS recommends is by default you select always 16. Okay, now let us do that calculation. So 24 means how much? 256. 28 means 16. Now let us go 30. 30 means what will happen? 30 minus 2 is what? 32 minus 30. It is 2. So 2 into 2, 4. Only 4 options we have. 4 IP addresses will have. But reservation itself 5. So we'll be able to use that 30. Will you be able to use that 30? Yes or no? Will we be able to use that 30 option? Because it's giving only 4 IP address. But normally reservation itself 5. Yes, so we will not be able to do that. Correct? We will not be able to take that. So now let us, we went beyond this. Let us come down. We mentioned 24, right? Now what about 22? If we keep it as 22, that is 32 minus 22 is equal to how much? 10. So 2 power 10. Now 2 power 8 is already 256, correct? 2 power 8 is 256. And 2 power 10 means what? 256 into 2. 256 into 2 is 512, correct? Now 512 into 2. 512 into 2 is how much? 1024. So 1024 computers I can attach through this network. This is nothing but simple. You have college, right? You have college labs. In the college lab, you have some 100 computers or 200 computers are there. Yes. Yes or no, guys? So, I think you will have your college email ID, correct? Now, your college email ID will work only in your college, not outside that. Why? Because they have put a list of IP address. This list of IP address, they don't want to display everything. They just put it 192.0.2.0 slash 20 or 22 we can mention. Once 22 is mentioned, automatically these 1024 IP addresses will be applied with the same rules. Will be applied with the same rules and they will get the same credentials. What are same credentials and same kind of permissions, whatever they have accessed. So 1024. Now this is one level. Again we'll go down. We put 22, right? Now again go to 30. 30 means what? So 30 means 32 minus 30, it is 12. Correct now? So 2 power 12. Already we found 2 power 10 is done. Correct now? 2 power 10 is done. So 1024 into 2 is how much? 2048. 2048 is 1. Again into 2. Again into 2. That is 4096. How much? 4096. So 4096 computers I can able to attach to a single network. This is how all your big companies are configured their companies internally. For example, you join Wipro. Now Wipro portal will be accessed only inside Wipro because they have the IP addresses. They will configure like this. They have IP address configuration. We are having a control over all the IP address from the main. Now this is how we can able to set. Now same thing. This is what we are going to set it to our VPC. That is our virtual private cloud. Okay. Now apart from this, we have other things. So I told you about 30. 20, 20 I mentioned. Okay, so instead of 20 I mentioned this one. 32 minus 20, 12. That's what I explained you now. Again we'll go for the lowest one, 16. What? 16. So 16 power 2 power 16. 2 power 16 is how much? That is 2 into 2 into 2 into 2, like that 16 will go. We already completed 12. Right? 12 into that is 4096 into again 2, again 2 will keep on going till 16. Now 2 power 16 is how much? How many IP addresses? 65,536 IP addresses. 65,536 IP addresses we can able to configure. IP address is nothing but computers. Like I said in the previous tab, all these computers in a one particular network. So this is 192.168.1.0, 1.2, 1.3, 1.4, like that. It will go for 65,000. So, but internally again is split into team wise or batch wise or whatever it is you want, you can able to split. Okay, now we have done 16-bit. One more is there, that is 32. If I put 32, already it's a 32-bit computer. Now what if we put 32 will happen? So 32, that ID alone will have one computer. That is only one computer will be there, one IP address will be there. There is one system. So that system we will, since it's having only one system, we can able to use this for a firewall configuration. Like slash 32, that is firewall. One computer is working as a firewall. Now in the other case also there. Let us take 32 we finished. We finished 32 is done. 24 is done. 28 is done. 30 is done. 20 is done. 16 is done. 16 is done. Now the other scenario what will happen if you put slash 0 slash 0. Now slash 0 means it is anywhere. Means anywhere IP address. Anywhere I can configure. It is like internet. Internet, that means you can able to access the any website using internet, right? So sir, that's what we are mentioning. 0.0 slash 0 dot 0 slash 0 means it is you are having the internet connection. So I have mentioned everything here also. You can able to write it. What is 32-bit? And 24 means you can able to see 2 power 8, that is 2 to 6, and IP address 32-bit slash 28 means 4, which is 2 power 4, and 16 LPA you can able to see 16 ELP IP address you can able to see 65,536, and 0.0 is internet, and this 192.0.0/132 is your firewall protection. Okay, so write this one and let me know once you have written, just to put a thumbs up symbol. If you're done, just put a thumbs up symbol. We'll move to the next one. Okay, done. Okay, next the OSI model. The OSI model. What is this OSI model? So this is an open system interconnection OSM. That means, for example, you are sending a mail from one person. You are sending a mail from one person. Let us take from the US to India. You are sending a mail. This is your main logic model of your whatever transaction you do from one person to another person, one server to another server, or one person to another person. So let us take B is in India. Now A is sending the data or a mail to the other person. Data or mail to the other person in India. Now how it is working, let us see. First, you are sending a mail. Let us take you are attaching a PPT or a PDF. Okay, that is your file. Let us go to your presentation now. First, it will go to the application layer. What is this application layer? Let us say you are using Gmail. So that Gmail is your application layer. That is your application layer. Next, it is mainly application to access your computer network. First, the application. Next, it will ensure the application layer read the data and encrypt it. That is, the application is able to read this PPT and you can able to put an encryption for it. Next, for example, this PPT might be okay. PPT, what are the sizes? It might be 3 MB or 5 MB, correct? So that 5 MB of data, how much time it will take to transfer? How much time it will take to transfer from this location to the other location, the user's location? So this session will calculate what is the time it will take, what time it will take to transfer. For example, they are saying 4.5 seconds, 4.5 seconds or 4 minutes. Seconds only. Let us take 14.5 seconds or 46. Let us take 46 seconds, 45 seconds it will take. Okay. Now 45 seconds it will take. It's maximum approximately calculating. It will take this much this file. For example, when you send a PDF or a PPT or something you are sending to other person, it will take more time. When you send a normal message, it will not take more time. Correct? Huh? Same thing. Next, it will go to the next level, that is transport layer. These are all one layers, one layers. First section, second section, third section. Like how you are building a product. You are building a product means it will have a lot of process and steps. The same thing, application, presentation, and session. Application, presentation, and session. Now this session move to the next level, that is transport layer. Here the transport layer is nothing but how we are going to connect it from US, how we are going to connect it to India, what network we are going to select. So it will select which network I want to communicate in India. Next, your package, that is your item. This PPT will get splitted into packets. Splitted into packets. That is like the big one is splitted into packets. That is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. This package will get splitted. Next, it will move to the data link layer. What is this data link layer? You might be able to see the connection for the network and some green light and red light are blinking. Have you seen that? Have you seen that in your networking? Some green color and red color. Green color means the data is able to transfer the data. Red color means no, the data is not traveling. I mean, it's not able to pass. Now, same thing here, the data will be transferred in the same LAN network, hubs and switches. Now, the last one, that is the physical layer. Physical layer is something about the tube. The tube means the wire is the physical layer. Correct now? So now this physical layer through this wire, how it will transfer? Now we have splitted this data into one, two, three, four. Like that, the packets will roll like one, two, three, four. Like that, we will have the numbers. It will go like the same order. One, two, three. We should not change. We cannot able to change anything. The packets will automatically go one by the order. Now, whatever layers you cross from USA, that is your person A, now it will go in the reverse order to the person B. Reverse order to the person B. Now he will start from here. Hardware components, all these data link layer, router, hub, switches, and all hardware components. Now again here this raw data will be transferred to the wire of the next person. That is the plan B. I mean the user B again From there, it will go to the data link layer. Now again, the data link layer is nothing but the switch we have currently, the router which we have connected is blinking. Now, sometimes you might be able to see the portal is working in red or green colors. Red means the data is not traveling or passing. Green color means it's going good. Next, you'll go to the transport layer. Transport layer again, it will be in the mid part of your OSI. It will transport. That is, it will pass the message that you have received. The host is receiving the data. Host has received the data. Next comes your session. Now, this session, what in the person B will do, it will also calculate how much time it took. We already mentioned 45 seconds there. Now, here you can mention 43 seconds. Okay. So now here you can say 43.5 seconds. Now, as I told you already, this is an approximately, this is accurate value which it will give you because we keep on adding data. We are passing this data. Okay, it will give that 43 minutes, 43 seconds I have done, I have transferred this data. Now coming to the presentation layer. Now comes to the presentation layer, which we have splitted, right? The data has been split into packets, and the packets are coming one by one, one by one, one by one, and the same order. Now in the presentation layer, it will get arranged, it will get rearranged. It will get rearranged. Now it will go in the same order. One, two, three, four, five, six, seven, like that. Now this will go to this application. For example, this user I told you is using Gmail. Now this guy, the other guy, the B person is using Outlook. Then that is your application where Outlook also will be open this PPT also. Okay. This is a normal process only. You can just write these layers of OSI model. Okay. Once you are done, just put a thumbs up symbol. You have written all the layers. Okay. We'll go for the next one. Put the heading as Amazon VPC. Amazon VPC. That is your Amazon Virtual Private Cloud. Now let us say Amazon is VPC, that is Virtual Private Cloud. What is this Virtual Private Cloud? So Virtual Private Cloud is nothing but the logically isolated section of your AWS cloud. That is, AWS cloud is bigger one. Okay. In that you are getting a space. In that you are getting a space. In that you can set anything, configuration, anything, settings you can give it a set. See, it can give you control over your full virtual resources, selection of IP address, creation of subnets. You can create this kind of subnets, and you can create the route table, that is your connections, and network gateway and network gateways. It will enable you to customize the networking configuration and you can enable use multi layers of security. Just now we learned a layers of open connection system. Open system connection is or open systems interconnection we saw. Na? Same thing, these are the layers. In each layer we can able to put some security also. For simple understanding, I'll tell you, you just understand this is a government this road, okay? You are creating a building or this is the owner, you are creating the building. Or let us take you are having a building, okay? You are having you are having I mean the house owner or the owner is having a building, okay? Now first floor, second floor. Now this is the floor you bought, okay? You bought second floor. Now this inside the second floor, inside the second floor, how the office setup should be. That will be decided by whom. You might have seen the owner will give a full empty building, correct? Floors around will be there and the empty building is there. Now you are taking an office, you are going to put a BPO office, let us say you are going to put a BPO office. Now, who will decide how the configuration of your cabin should be, how the office setup should be? Will be decided by whom? Either by you, the buyer. You have bought the second floor. Buyer in sense you take for rent only. Will you decide that, or the house owner will decide that? The building owner will decide. Who will decide how this office setup should be? This office setup should be. Who will decide that? Whether the owner will decide or you will decide. You bought this second floor for rent. How to set up all these things, the configuration, rooms, cabins, and everything. Who will decide that? Can I just post in the chat box? Owner will decide. Why owner will decide? You bought the rent. You go for rented house. Will the owner will come and say where you have to keep the fridge, where you have to keep the TV, what you have to do and everything? Yes. So who will decide? The person who got the rent, right? He will decide. Now, same thing here, you got the cloud space, that is VPC, you got it. Inside that, how to create this subnet, that is cabins, let us take. IP address is your computer. How to get this IP address? Everything will be decided by the person who, the guest, you are the guest, right? You are the guest user. That means you took the rent only. On the chat, what are the So you are going to decide, right? Same thing only in this building. What cabin? There is HR cabin. This is sales cabin, operations cabin, IT cabin, development team cabin, recruitment team cabin. Everything will be decided by you. In this, how many computers I want to put? How many computers I want to put? That also will be decided by me. Are you getting? And how to put security? That means every room will have a lock. And how can you put a lock actually? A lock in sense, will you allow the HR team to log in or open your sales team's door? How will you access? How will you give access? What you have to do? How will you give access to HR room? Have you, can you put a security for that? Security means not security person. I'm asking you how to put the security. How to put the security? How will you put the security? Come on, guys. Have you gone to any offices? How people are logging into their premises or how they are going inside their office? Is generally every office are open normally? How is it actually? How is it actually? How you are logging into a company or going inside a company? What you need? What you need? ID card. Yes, exactly. ID card. Correct. Now ID card swipe you have to do. Now only when you swipe your ID card, it is allowing you to go inside. Correct. Now this is one type of security. Same thing. I can able to put security layers needs this subnet level or system level also. I can able to put. How we are protecting your system? How you are protecting your systems? Will you allow everyone to access your system? What you need? You need. How will you log into your system? Yes, password, correct na? So same thing, you can able to set some security things. Fine. Now, inside this subnet, inside this VPC, that is your virtual private cloud, like the building I told you. Here you have VPC, you have subnets. There we have two types of subnets. So here you can see VPC is inside availability zone, multiple availability zone. Across that you have a VPC. VPC and availability zones are inside regions, which we already learned. And both again regions, availability zone, everything is in the AWS cloud. Now here we have public subnet and private subnet. Public and private. Public means what? Public means anyone can able to access. That means anyone can able to see it. Private means no, only the owner and the desired person alone can able to access it. Now logically isolated from other VPCs. That means what? See, I just draw the floor, correct? I just draw the floor. You bought second floor. That is your VPC. Okay, inside this whatever you want you can build. Now this first floor person is also having some other office. Can he come and disturb you? Is it right? Or can he able to do it? Yes or no? No. Correct na? So he don't have the rights to come and disturb you. So that's the same thing. Inside this VPC, your VPC is isolated even though you are in the same cloud. So this is cloud. The building is the cloud and the floor is the VPC. If this floor will not disturb this guy will not disturb this guy. So everyone are isolated. Now it is only dedicated to your account, belong to a single region and multiple availability zones. You can able to span it to multiple again third availability zone also you can drag it. Next, what are the range of IP addresses and divide a VPC? You can able to divide the subnets by having creating the CADR block range. We learned in a CADR block range we can able to create. Then which is belong to a single availability zone. Then it will belong to a single availability zone. Now here as I told you the subnets can be classified into public or private. Public or private. So write this one and keep it. It is isolated section. It is range of the divider belongs to some model. Subnets means what? Learn as well as public or private. Okay, you're done. We'll go to the next one. Now for easy understanding, I have put a picture. You can able to see what is the subnet, what is the so VPC. Inside VPC you have private network, public network, and NAT gateway, internet gateway. So all these things are there. Now private is you see they are having this tomato in the column they have tomato. Now that will be taken inside from this NAT gateway. From this the machine is giving to the public. From public they are giving to the public entrance. That is your public user. Public subnet from public subnet public can be able to access. Private subnet only private people. That is you are the owner only able to access it. Okay. You can able to see this NAT gateway and internet gateway. I'll tell you, but this here able to see this. Understand? Can you allow this public to go inside this? Will you allow? No. Correct, na? Yes. Same thing. Public cannot go inside private. But private can, this guy can come out and mingle with these people. Is it possible? Yes. So that is can be possible. So private subnet, if you want to access public, internet or something, it can able to access. But public cannot go and enter a private subnet. Okay. Now, what is this IP address? We already discussed about IP address range. So we can able to give the IP address. So first itself we have to define the CADR block range. That is how many IP address I am going to put for my VPC. So what is the maximum highest one? As we learned already, 16 is the highest one, which will have 65,536 IP address. If you create that, if you select that 65,536 IP address, then first itself you have to go for 16. Why first itself you have to go for 16? Because you cannot change the address range after you create the VPC. After you create the VPC. It's a simple concept, same thing only. You have the building, right? Uh, Second floor is there. You want to build extension. Can you able to build it? You are a rented person. Do you have the permission to build extra rooms and everything apart from the what the building owner has given to you? Do you have the permission to do that or will you do that? No. Correct, na? Same thing only. First time itself we have to define how many IP addresses I will be expecting. Now, why we want to give the 16 first itself means, as per AWS, we are going to pay only for what we use. We are going to pay only for what we use. So we don't need to worry about whether it will be more. If more IP addresses we are taking, but whether we'll be using it or not, whether we'll be going to pay for that. No, we're not going to pay for that. But when you launch itself, you give for higher configuration. That's what 65,536 IP address. Next, 16 bits. Okay, this is the highest one. Which one is the lowest one? Which is the 28 one, because it will have 4 IP address, which is only 16 bits IP address. 16 IP addresses are only available. So the largest one is 16, smallest one is 28. And the CA block of subnets cannot overlap. That means whatever you have written in the block, you cannot overlap. That means, for example, here you have two subnets. Two subnets. Now this IP address is 192.168.1.1. Now it's here 198.168.1 sorry 1.1. So both are 1.1, 1.1 means this subnet will overlap this subnet. So that will not happen. That should not happen. It will not work. Our same IP address should not be reflected in the other subnet. Okay. Next, as I told you, they are going to reserve 5 IP addresses for reservation. So for what purpose we are going to reserve these 5 IP addresses? Okay. So this one, as I told you, this for example, this is the best example. Here you can see VPC subnet 1, subnet 2. So 16 digits we are taking. 16 digits means 65,536 IP address we are taking for this VPC. In that slash 24, that is 256 IP addresses we are blocking for 0.0. Again 0.2, okay, 1.0 is 252, 256, and again subnet 2, again 256, again 256. So overall 256, overall 4 256 is how much? 1004, correct na? 1004. 1004 or 1024. Okay. Now as I told you all the IP addresses, we have 5 IP addresses reserved. 5 IP addresses reserved. If you are reserving 5 IP addresses, what will be there? Only 251 will be there. So 251 into 4 is how much? 251 into 4. How much? 1004. So this 1004 IP address only used. Remaining will be there, na? Because you have already launched how much? 65,536. 65,536 IP addresses minus 1004. Then we have what? 64,531. 64,531 address remaining is there. Still you can able to use. Okay. Now coming back, why I want to reserve this 5? First reason. First we have to block this, reserve this 0.0 first one. Mainly for the network address. I want to find my network category, for we have to block this one 0.1. Next 0.1 for internal communication. What is this internal communication? Means this is a subnet I told you. Subnet means what? Your cabins. Your cabins. As per our imagination, it is cabins. Now these systems only your systems are nothing but you. You guys are sitting inside the office, na? So you are the systems. Now can I allow these people to communicate among themselves or not? Hmm? In the let us decide like it's in your classroom, your college is right. So you have classroom, you have BSc, BCom, everybody. Will they say that don't talk each other? Will they say don't talk among yourself? Maybe if you are shouting like anything, they will say. But I'm asking. Yes or no? No. Correct. Now, because they have to communicate. For that same thing here, the system has to communicate each other. Why the system wants to communicate each other? If there is any issue, like why they were allowing you to talk inside the classroom or the students has to talk each other. If something emergency, it has to be passed to the lecturer. It has to be passed to the appropriate person. So for that, the communication should be allowed. Correct. Same thing here. The internal communication is allowed among this computers. These computers will communicate each other later. For that, that should be available. That means the communication channel should be open. So for that purpose, we are blocking this one more. Next, the third one, domain name system. You don't know domain, you know domain name system, right? Domain name system is what? You are typing something, www.amazon.com. Amazon.com is what? It's already a server. So first it has to go redirect to that particular server. Redirect means it will first go to that IP address. From there it will redirect. Okay, so domain name system. I want to register this domain. Next for future use, for everything is gone. Now all the 68,000 files this is over. I don't have any ID for emergency. So for that what we can do? We can able to mention the, for this we have blocked this 10.0.0.3, which is for future use. Next last one, 0.255. This is nothing but a network broadcast. That means you're broadcasting your website or something like live YouTube channel or they're going. I think live Instagram also they're going, right? Lively they will talk, capture, do. So at that time our link should work properly. For that we are using 10.0.255. Okay, so these are the reasons for the reserved IP address. Fine. If you're done, just put a thumbs up symbol. Why reserved IP address? Okay, we'll go for the next one. Next, public IP address and elastic IP address. What is this public IP address? So public address means public can able to access it. Public can able to access it. So manually assigned through an elastic IP address, it's automatically assigned through the auto assigned public IP address. Auto assigned means automatically when you go for a public subnet, whatever servers you have kept it in the public subnet, it will be accessed by the public. Okay. Now for example, this server is there, which is allowing, let us take cricket.com. Cricket.com. Cricket.com is running on this server. Now we have to put auto assign since it's already public are seeing public are seeing the watching the game, the cricket they're watching. Now this elastic APIs, we are going for an elastic APIs. What is this elastic APIs? Like in a car, you have tires. How many tires you have in a car? Four. Sure. You have only four tires in a car. Any other tires? Yes. What is the fifth one? What is the fifth tire we call? The stepney tire will have, right? So now when will you use this stepney tire? Let us take you got punctured. Your car is got punctured. What will you do? You will put the puncture, or will first maybe you're in the middle of the road somewhere which is not near to the city also. What will you do? Will you use the stepney? Okay, yes, we'll use the stepney. Okay, fine. What about the puncture tire? What you will do? What will you do that the puncture tire? Okay, you'll go and put the puncture in the next nearest shop or not? Yes. Okay. Now same thing here. We have to take an elastic IP address that is like a stepney tire. That means whatever this server is running, this is the server which is running in the IP address called 192.8.51.100.2, where public is watching the cricket. So your server got repaired. Your server got repaired. What should happen? Automatically the server has got repaired or crashed means The public who are watching the cricket will get disappointment, right? It will the cricket will go. No? They will not be able to see. Correct? It will not be visible. So to avoid that automatic crash, what we have done, we have to take an elastic IP address like your stepney tire. When you assign an elastic IP address for this address, what will happen? Automatically, once this is crashed, automatically it will move to the next one. Again, this is crashed, the next one. Again, like your stepney, how we are going to do the puncture for the original tire and keep it. First time when your server got failed itself, AWS will take care of that. Because AWS main job is that, right? AWS will take care of that. What is the issue? What happened and everything. They will try to fix it fast and will bring it back. But meanwhile, the customer should not get affected. The customer should not get affected. So that is called mask the failure. Mask the failure. What we call it as this elastic IP address. We call it as mask the failure. So here in this diagram, you can able to see that whatever I told you. You see public IP address that is 10.0.10.5. This is your server. This is your CPU number. Now this one is your IP. This is the public IP which you are given to the public they want to access. Correct? Now this server got repaired. Now what will happen? Immediately this will move to the next one. You see the server, the same server alone different, but the IP address is same. You see 198.5100 dot. Okay. Now this is called as what? Elastic IP address. We call it as called what? Mask the failure. Why mask the failure? Because when it gets failed, we are not showing it to the public. We are not showing it to the public. Users are still able to access that website without knowing that the server has been changed in the backend. But since it's a additional thing which we are doing, so it will be having additional cost. The cost might be high. See, additional cost might be applied. Can be allocated and revamped anytime associated with an AWS. Then you are done. We'll go to the next one. You understood, guys. Can you just put a thumbs up symbol if you understood this mask the failure? So I think when your time of going for this cricket watching, live watching, you'll be able to see sometimes the TV will refresh one more time immediately by automatically. That means the server got changed in the backend. 1 second only. 1 second it will keep on tuck. It will change. So you can easily understand something happened in the backend. So that's just nothing but the server got changed. Next network interface. Network interface. That is nothing but it's like your. Let us take a flower pot. You take a flower pot. You have a pipe in tube. So this elastic network interface, this is a virtual network interface. It's just an interface where it will get attached to the CPU, attached to the server. Server is nothing but instance, attached to an instance and detached from an instance. Whenever it is adding with another one, another server is running, it will attach to that. Another server is there, it will attach to that. Why it is attaching? What is this one? This is another level of security where it will just control the incoming and outgoing traffic. Okay, so when it will do this, because it's going to attach release whenever you are using, just like with this pot thing, the flowers I want to pour water on these flowers. So first I'll take the tube to the first flower, correct na? So it is called attaching. Same thing here, the interface is attaching the server first time. Okay, when it is running. That's what for pouring this water in this flower. I'm taking this tube. Now I want to pour water for this second one. Let us take one, two, three. What we have to do? The second floor, the second part. Again, we have to change this tube to this here, right? At that time, the tube will not be accessible by the first one, correct now? Same thing, this one is attached. Same thing here, this network interface will attach to this server. It will control the incoming and outgoing traffic. And again, the second one, if you start a new, that will go and attach there. So each instance in your VPC has a default network interface that is assigned to a private IP address only. So where this assigned means it's not in the public address, it will be there attached only to the private IP address from the IPv4 range of your VPC. So this elastic network interface will be there only in the private subnet, not in the public subnet. Are you getting this? Yes. Okay. Next one, the route tables and routers. Route tables is nothing but like your traffic constable. Let us say what is the transit traffic constable will do? He will be in the center of this. There are four roads. What is the main job of a traffic constable? Someone don't know any route, nothing. He wants to go to some place. Let us say Panchankari, he wants to go from Silk Board. He is standing in front of Silk Board. The traffic police is in the center. What he will say? He's going and asking the traffic police. What he will say? He will show the way. Yes, go this side, go that side. Yes, exactly. Same thing. This route table is going to route the traffic between public and private. Also, it's not like two things. It's not like one public. One route table will be having separate route table for public, and this is route table. Let us take this is public subnet. This is private subnet. For private, we have another route table that is your private sub route table. Now here you can see destination target, destination and target. So the destination is 10.0.0/16 and the target is local. Target is local means local communication. We learned now na local communication is allowed. So when we mention the destination is /16, that is 65,536. All the IP address can communicate locally, communicate no issues. Destination, what you want to transfer, that you can have to mention. So each route table will specify a destination and a target. And each route table will contain a local route also, as I told you, mainly for communication within the VPC, we need this. Next, each subnet must be associated with one route table. Each subnet must be associated with the route table. Associated with the route table, at most one. Also, a route table can have multiple subnets. That means route table can have multiple subnets, but subnet at least should have one route table. Subnet at least should have one route table. Are you getting? First write and keep this one. Each subnet must be associated with route table, at least one. Also, a subnet can have multiple subnets. So, subnet, route table, multiple subnets. This is possible. But subnet at least connected to one route table. And it will have destination and target. So once you are done, just put a thumbs up symbol. Okay, everyone done? Yes. Kiran, can you read it?
Yes, sir.
Yes.
A VPC is a logically isolated section of the AWS Cloud. A VPC belongs to one region and requires a CIDR block. A VPC is subdivided into subnets. A subnet belongs to one availability zone and requires a CIDR block. Route tables control traffic for a subnet. Route tables have a built-in local route. You add additional routes to the table. The local route cannot be deleted.
Okay, fine. So we will see the remaining things VPC networking tomorrow. Okay. Okay, guys. So not done the lab. Just to try to run the lab, and once I finish the networking, I'll do the networking lab and security lab as well. Okay. Thank you. We'll see you tomorrow at the same time. Yes. Thank you, Manasan. Thank you, everyone.